Hello, astronomy and meteorology students. It's Mr. Johnson here. I wanted to check in with you and do a few short videos to summarize the material you've been learning on your own about the moon over the last couple weeks. It's not a bad idea to take some notes over this. That way you don't have to memorize everything. Remember, you can always go back and rewatch these videos. Do plan on having a test or a quiz over the solar system and the moon in the very near future. The solar system, I'll remind you, we learned when we were still in school. I will have notes posted for that. And the moon you learned on your own, and I will post notes and these videos for that also. So let's get into things a little bit. I'll remind you that our star started just like every other star. It was a nebula that condensed down into a protostar, and that condensed further, began nuclear fusion, making the main sequence star that we enjoy today. So all of this happened about 4.6 billion years ago. That main sequence star formed, and the gas and dust, when that protostar was forming, it condenses down and it starts to spiral, and that causes this kind of flattened disk shape to form around it. That gas and dust collected together to form smaller objects that eventually formed smaller planets. And over time, there became less planets, but they all became a lot larger. So we started off again, 4.6 billion years ago, our solar system formed. Many smaller objects over time clumped together, making larger objects, but there were fewer of them. Now that leads us to our moon. Well, the moon actually formed after the Earth. So the solar system formed 4.6 billion years ago. The moon formed about 4.5 billion years ago. So the Earth and the moon is what we're going to cover right now. I'm going to discuss the formation of the moon and a little bit of the lunar surface. So again, like I said, about 4.5 billion years ago, a small planet called Theia impacted the Earth. This is fairly soon after the Earth formed. And what that did is that flung debris from the Earth up into Earth's orbit. So it was flying at a fast enough speed, but it was still held onto by gravity, and that debris orbited the Earth. Well, just like the planets formed by collecting together of material in space, the moon formed by collecting together material after it was flung into space by the impact from Theia. So one of the strong bits of evidence that there is looking at the lunar surface, looking at the material that makes up the moon and comparing it to the material on Earth. And as it turns out, it's essentially the same composition as just the surface of the Earth. So that's pretty compelling evidence. Now, since then, the moon went through its own formation, and if you haven't watched those Ed puzzles, make sure you do those. But back when the first map of the moon was made, this is actually what it looked like. This is the first map of the moon. Well, back then, when you looked up at the moon, we'd see sort of these dark regions, and they assumed that they were seas or oceans, and so they gave them fun names like the Sea of Showers and the Sea of Moisture, the Sea of Clouds, the Sea of Vapors. These are all interesting names given to things that they thought were seas, and as it turns out, they are not seas. When the moon was first forming, it had lava also, and those lava fields cooled, forming more or less these flat areas. Now, during the moon's formation, there was also movement that caused mountains to form, and there's been many impacts from meteors since then. So we can see that there are craters like the Tycho crater is a very easy one to see. The Copernicus crater is another very easy one to see. And then these dark regions, which again are called seas or ocean. I think there's one called an ocean somewhere around here. But anyway, an interesting thing to point out about these craters is when the asteroids impacted the moon, debris was flung out in all directions. And so we can see where it landed. There are raised sections that are called rays heading out from that middle crater. We can see it here too if you look closely. You can see these kind of stretch marks. Well, those are actually raised bits of the moon surface caused by debris that was flung out when it got impacted by asteroids. Now, like I said, we've come a long ways since even these names, but it's kind of fun to look at these names and identify different parts of the moon on a clear night with a full moon. So there are even more detailed maps if you want to know. There are certain lands that have names, and you can even find where different missions to the moon have gone, different moon landings. All right, I think that'll be the end of that video. You can check for more videos coming up. I hope this has been helpful.